My name is Eric Kai. I work as a senior analyst in advanced analytics at Acosta. And tonight, I will provide a different focus from Pritish and Yi-Chen because, number one, I will focus on traditional retail in physical stores. So Pritish and Yi-Chen focused on e-commerce. I will focus on the shopping that happens in brick and mortar stores. And secondly, I focus on consumer packaged goods, which is the industry that I work in. Consumer packaged goods are marked by several key characteristics. There are frequent purchases, there's rapid consumption, the prices generally tend to be low, so it's not like furniture or luxury clothes. There tends to be high volumes of packing and shipment. There's widespread distribution, and there tends to be low consumer engagement. So what that means is shoppers usually just go into the store and they buy the product. They don't usually take a lot of time to try it out. You can't really try out a CPG product anyway, usually. They usually just go in and grab it, put it in their shopping cart, go to the checkout, buy it, leave the store. So it's not like furniture or cars or clothes where there tends to be more consumer engagement, perhaps more engagement on social media. CPG it tends to involve low consumer engagement. So these are just generally the characteristics for CPG, which is also known as fast-moving consumer goods, or FMCG. Okay, so some examples of CPG include canned soup, snacks, and toothpaste. So those are just 3 examples. Okay, so Acosta, how does Acosta fit into the CPG industry? Acosta is a sales and marketing company that's located in Canada, the USA, the UK, Australia, and Ireland, and it serves the suppliers of consumer packaged goods. So some of the major clients of Acosta include the Coca-Cola Company, Kellogg's, Campbell's, the Clorox Company, Colgate-Palmolive. And Acosta sits in the middle between the suppliers and the retailers. So the suppliers, like the Coca-Cola Company, would sell the consumer packaged goods to the retailers like Walmart. And Acosta would act as a sales and marketing company for the Coca-Cola Company or other CPG suppliers. Now, one of Acosta's core services is called retail coverage. And this is something that I did not know about until I joined Acosta. And it's perhaps not familiar to most people as well. So what is retail coverage? It is a service that our field associates provide. So our field associates are technically called retail merchandisers. They visit the retail stores on behalf of our clients. And they ensure that those retailers, those stores, are ordering, stocking, and displaying our clients' products properly. So I'm going to show you a video from our company's hiring website just to show you what a retail merchandiser does. It's a very short video. Our field associates bring electronic devices to track what they're supposed to cover when they're visiting that store. So they have the products that they're supposed to cover, the particular varieties, the prices, the promotions. Perhaps there's a special coupon or promotion that they need to display on the shelves. Perhaps there's a special display for promoting the product. So you saw that there was a tent earlier near an aisle. So our field associates do a really critical job for our clients, the CPG suppliers, to make sure that their products are being ordered, stocked, and displayed properly at the retailers where they're supposed to be sold. So this is one of the core services that we provide, and it wasn't something that I immediately understood when I first joined the company, and so I hope that this video and this introduction helps you to understand how Acosta fits into the overall retail landscape for consumer packaged goods. Okay, so what do I do on the team? My job is to use statistics to measure the impact of retail coverage on sales. So our CPGs, the CPG suppliers, our clients, have to pay for this service, this retail coverage, and they would like to know if they're getting a good return on investment on the retail coverage. So hopefully, when I use my statistical methods to measure the impact, it will be a nice big positive number, and I could say to our internal business team, who then will talk to our external clients and say, Acosta's retail coverage increased the sales of Coca-Cola at Walmart by $50 per store per week. Something like that. I'm making that number up, but that gives you a sense of what success looks like. For me, anyway, my job. Now, how do I actually measure the impact of retail coverage? I use a test and control approach. So what happens is some stores get retail coverage, and I'll call these stores the test stores, and some stores do not get retail coverage, and these are the control stores. So this is somewhat analogous to what Yi Chen just talked about in her presentation just before mine. Now, this is a diagram to show you what that looks like. So you start off with all the stores under one retailer. You split off into some test stores and some control stores. The test stores are the ones that get retail coverage. The control stores do not. And then you measure the sales revenue. And you compare the revenue between the two groups, and hopefully the test stores will have higher revenue compared to the control stores. Now, my question to you, the audience, is this a randomized control experiment? This is not a randomized experiment because the population of the stores is not homogeneous to begin with. You can't control for the fact that some stores, the stores have different managers. The incomes of the surrounding neighborhoods are different. The competitors nearby the stores are different. And of course, the locations are different. And so the weather patterns, therefore, are different, okay? So there are many things that you cannot control for. So this is not technically a randomized control experiment. So there are other fields where you can run randomized control experiments, like chemistry, for example. I used to study chemistry for my bachelor's degree. You can definitely run randomized control experiments here. You can do that for physics. You can do that for medicine. I think that in certain circumstances in e-commerce, you can, especially if you're doing digital analytics, if you're doing A/B testing, you can get a fairly homogeneous population, and it is a fairly randomized control experiment. But when it comes to measuring the impact of retail coverage, it is not a randomized control experiment. So the problem with that, so how does that affect us? It means that when I try to compare the sales revenue between the two groups, I cannot be absolutely sure that the retail coverage is the source of the increase in the revenue. That increase in the sales revenue for the test stores could be due to the other factors, what we in statistics would call the confounding variables. So it could be because the test stores have better management, or because the test stores have higher incomes in their surrounding neighborhoods, or because they have fewer competitors nearby. Okay, so this is why a randomized control experiment is so nice. It's because you can control for those confounding variables, and therefore the only variable that differs between the two groups is the variable of interest, and in our case, it's retail coverage. So how do we overcome this problem? So at Acosta, we have developed a proprietary software in Python to implement some sophisticated mathematics that overcome the confounding factors and compare the sales between the test and the control stores. Unfortunately, I am not allowed to talk about what this proprietary software does, and I'm not allowed to share any details Unfortunately, all of this is confidential. Okay. But there are still some lessons about this measurement of retail coverage that I would like to share with all of you. And in the second half of this presentation, I'm going to show you a tool that I use, that I've learned to use in my job to do data analysis. Okay, so let's suppose that Acosta's retail coverage increases the sales of Classic Coke at Walmart by $50 per store per week. So let's assume that we have successfully controlled for the other variables that may contribute to sales. Does this automatically imply success for the Coca-Cola company? So we're looking at Classic Coke, and I've used my fancy Sifit mathematics and statistics. I have used our special software to control for those other variables, and I found that Acosta's retail coverage increases the sales of Classic Coke by $50 at Walmart per store per week. Does that automatically mean success? The answer is no, it's not, because the increase in the sales of Classic Coke may cannibalize the sales of other products from the Coca-Cola company in the same aisle. So the Coca-Cola company doesn't just sell Classic Coke. It also sells other products like Diet Coke and Sprite and Nestea. So if we use retail coverage to boost the sales of Classic Coke, that may decrease the sales of the other products that the Coca-Cola company also sells. So we do not want that to happen. And this is why it's important that we assess the entire brand of products that the Coca-Cola company sells at a shelf. So here we see a bunch of Coca-Cola products, but we also see Sprite, okay? So that is a product that the Coca-Cola company also sells. So if retail coverage boosts the sales of Classic Coke, but it decreases the sales of Sprite in equal magnitude, then the end result is the Coca-Cola company hasn't really increased the sales of all of its products. So the lesson here is when you're assessing retail coverage for a CPG supplier, you need to measure the incremental impact of all products in the same category from the supplier. So that is a key lesson that I've learned in my job. You cannot just assess the product that you're covering. You have to assess all of the products in the same category from your client. Okay, so that's the first key lesson. The second question is, now let's suppose that I have answered that question, and yes, all of the products, so I do retail coverage, and it turns out that both Classic Coke and all the other beverages from the Coca-Cola company increase in sales. So the overall category from Coca-Cola increases in sales. So does this automatically imply success for Walmart? Remember, Walmart is the retailer. So Coca-Cola, the Coca-Cola company is the supplier. Walmart is the retailer. So does the success of the Coca-Cola company imply success for Walmart? It's the same idea, because the increase in sales of the Coca-Cola company's products may cannibalize the sales of other brands from other suppliers. So for example, Pepsi, A&W Root Beer, Crush Orange, these are products from other clients that Walmart may be selling in the same aisle, perhaps on the same shelf. And so for Walmart, if the increase in the Coca-Cola company's sales is canceled by the sales of is canceled by the decrease in sales of these other products to an equal magnitude, then that's not good for Walmart. It's good for the Coca-Cola company, but it's not good for Walmart. So ideally what Walmart wants is an increase in coverage for a product that draws customers to the aisle, which then incentivizes the shopper to buy other products on that shelf or in that same aisle, in addition to the product that's being covered. Now, here's a key question that I had to answer for myself when I was learning about this is, the Coca-Cola company is our company's client. technically speaking, Walmart is not Acosta's client. So why should Acosta care about Walmart's revenues? It turns out that Walmart is the biggest retailer in the CPG industry, and that's probably not a surprise to most people. The Coca-Cola company wants Walmart to buy its products, which makes sense. If Walmart is the biggest retailer, then the Coca-Cola company would want Walmart to buy more of its products so that more of its products are on the shelves and more of the products are then available for shoppers to buy. And it turns out that many suppliers compete for the same shelf space at Walmart to sell their products. So it would be good for the Coca-Cola company to establish a win-win situation with Walmart. So can we find a product, or can we find a retail coverage scheme that boosts the overall sales of that category of products for both the Coca-Cola company and for Walmart? That would be the ideal scenario. Okay, so that is why Acosta cares about Walmart's revenues. So those are some of the key lessons that I had to learn as I was getting to know the business of consumer packaged goods and retail coverage. Okay, so to summarize, when you're assessing the retail coverage for a retailer, you need to measure the incremental impact of all products in the same category in the retail store. Okay, so before, our key lesson was, if you're assessing retail coverage for the supplier, you need to measure the impact for all the products in the same category from the supplier. But if you're doing it for the retailer, you need to do it for the same category for the store. Okay, all right. So those are the business lessons. Now let's move on to some data analysis, some statistics, some data science. So those are the general. So what I just talked about was the general business scenario. How do we actually measure the impact of retail coverage? Well, first of all, we need data. So here's some of the key ingredients. So first, we need a store identifier. For most retailers, that store identifier is a number called a TD links. The exception is for Walmart. So Walmart has its own system, which is called the Walmart store number. Okay. We also need to identify the products of interest. So what products are being covered under retail coverage? So for most retailers, the product identifier is the Universal Product Code, or UPC. That's the code that's denoted by the barcode that you see on products that you buy from stores. Okay, and again, for Walmart, there's an exception. So Walmart has its own system. It uses something called the Walmart product number. Okay, once you have both the store identifier and the product identifier, you can then retrieve point of sales data, or POS data. Okay, so once you get POS data, you can then do your analysis, or in my case, I'm going to use the proprietary software that Acosta built to measure impact using the impact of retail coverage using the sophisticated mathematics and statistics that we developed. Unfortunately, as I mentioned before, that software is confidential. I cannot share that with you. So instead, I'm going to teach you something new that I also learned at this job. And it is this software called KNIME. Okay, KNIME is a point-and-click software for working with data, and it can do a whole bunch of things. It can do data extraction. It can do data wrangling. It can do data analysis. It can do statistical modeling. It can do machine learning. Okay, and it has a drag and drop interface that connects nodes together to create a workflow. And the best thing about KNIME is the desktop version is free. Now, this is what KNIME looks like. Okay, so as I mentioned before, you drag and drop the nodes. So on the bottom left here, this is the node repository. So you can use the search bar here to search for whatever node you want, and then you can drag it onto the canvas, and you can connect them together to do whatever it is that you want to do. Okay, now does this interface remind you of any drag and drop software that you have, commercial drag and drop software that you have seen for data science? I encountered a software that is called Alteryx. And Alteryx is very much like KNIME. It's drag and drop. You connect the nodes together. As I mentioned, there's also SAS Enterprise Guide, SAS Enterprise Miner. However, all of these platforms cost money. KNIME offers a free desktop version. Okay, so the server version does cost money, but for the desktop, it's free. And I was talking to a colleague of mine who was thinking about using a commercial software, and he works in a nonprofit organization. And so he was asking me about Alteryx because I used to use Alteryx in another job. And I said to him, hey, but I just started working at Acosta and I learned about this free drag and drop software called KNIME. And he was ecstatic. So let's go to KNIME and actually go through a demonstration of what KNIME can do. So here, I'm going to start with the file reader. So here we have the data set that I'm going to import. And this is a fake data set with fake data, but it resembles very much what I generally work with. So so before you even run the node that imports the data, it will give you a preview of what the data looks like. And what I really like about this option is that if the data happens to be in a different format than it should be, you can control that using this drop-down menu when you click on the column name. So when I first imported this data set, actually, TD links was a number. So it was, I think it was an integer. It saw, yeah, and that's understandable. It saw these numbers as integers, but this is actually not an integer. This is a string. And this will become important in the next node that I'll run. So I like the fact that I can change the variable type when I'm importing the data, okay? And there are a bunch of options up here that, as you can see, it's important. Most data sets that I work with have column headers, so I make sure that I check this option. Okay, so there are a few other options that I want to show you. So the TD links is a 7-digit number. So if it's 6 digits, then what most likely happened is that there were some leading zeros that were stripped away or just not caught by the file reader node. And so you can use a string manipulation node to pad zeros to the left of the string, okay? Here I am choosing to exclude one variable and keep the rest. What I really like about this interface is that you can either enforce inclusion or enforce exclusion. And you can move around a whole bunch of variables at a time without doing everything, clicking on each variable one at a time. So I could put all of these variables back in here, and I could say, well, okay, I want to exclude TD links, so I'm going to move everything here, but I'm going to move TD links back here, and I'm going to enforce exclusion, okay? I can use this node to change the order of the columns as they appear. So if for my own sanity, oh, by the way, so whenever you want to run a node, whenever you finish running a node, you can either click this button or you can right click and look at the output data to see what it looks like. So previously, when I did the string manipulation, the store number that I created that had the padded zeros, that was on the very right. So I wanted to move that to the very left. So that's for my own sanity. Okay, so this node is very useful because I need to make sure that the date that I import is actually a date and not just a string. So this node takes care of that for me. I could either create a new column or replace the selected column, okay? The row filter, another really useful node in case I want to exclude certain rows. This is or include certain rows. So another thing I like about this interface is that I can exclude or include. And if I choose a particular variable on which I want to enforce the exclusion, KNIME will tell me what values are available for me to choose for that criterion. So here I want to exclude the small size. So I'm going to include large and medium, but leave out the small. Okay. Okay. So that's the data wrangling. So here, the group by node, another really useful node to have. This node here, let's actually go through what it looks like. So I think that most people who work with, say, Python, I think I use Python in my day-to-day job. If you use Python and you use pandas, you probably are familiar with the group by function. The group by function works in the same way here. You are doing some operation while grouping by some categorical variable. So I have two. So if you go back to this file reader, we have two cities. We have New York, we have Orlando. So I want to know how many stores are there in each city. So I'm going to group by city. So here on this tab, I'm going to group by city, and here I'm going to count the number of unique stores. And this here is actually a menu that allows me to choose which statistic I want to use to measure. So I've chosen to do to get the unique count. And of course, if you care about missing values, which I often do care about, then make sure to click the check mark for this. Okay, so that is a very important data analysis node that I use. And finally, let's do some statistics. Let's actually do some predictive modeling. So it turns out that KNIME has a whole bunch of really cool functions for statistics and machine learning. So you can do linear regression. You can do logistic regression. Here we see decision tree. There's gradient boosting. There's random forest. There's neural network. Okay. And if you type SVM, you'll see that there's support vector machines on the left. So I'm going to use linear regression, and I am going to use units sold as the predictor variable, and I'm going to predict the sales revenue. I'm using this just to illustrate linear regression in KNIME. Okay, I don't think there's too much business value that you can extract from that, but but from a statistical point of view, I think that this is actually a good opportunity to demonstrate something important here. So in linear regression, we have the model. Let's use a thicker pen. So yep. Okay. So the linear regression model is yi is equal to beta 0 plus beta 1 xi plus epsilon I, where epsilon I has the normal distribution with 0 as the expected value and sigma squared as the variance. So we have three parameters to estimate in this model: beta 0, beta 1, and sigma squared. However, if I am using units sold to predict revenue, should I be using all three parameters in this model? That is a question for you, audience. So I'm using units sold. So this is units sold. Units sold. And this right here is revenue. So if I'm using units sold to predict revenue, should I be using all three parameters in this model? So the answer is no, you should not be using all three of these. This right here is the intercept, okay? What this intercept parameter means is if you have 0 units, what revenue would you have? Well, if you're not selling any units, you can't possibly have revenue, right? If the number of units that you're selling is 0, then you better be, for the products of interest, you better not have any revenue, okay? So for this particular model, it is important that we fit the model without the intercept. Okay, so as a statistics lesson, this is why when you're using KNIME, if you're implementing linear regression without an intercept and you want to enforce the lack of an intercept, you need to use a predefined offset value equaling 0. Okay, so and to look at the result, you would click right click and you can go to linear regression view and you can see the results there. So units sold has a coefficient of 7.4004. This 7.4004, that is our beta 1 here. So this is denoting that on average, when we sell one beverage from this store, we are earning $7.04 in revenue. Okay, so I use that example to illustrate a bigger point, which is if you're running a statistical model or a machine learning model, you better understand what you're doing. You need to understand the math behind the model, and you need to adjust the math based on the business circumstances or whatever practical situation you are modeling, whether you're working in biotech, whether you're working in government, whether you're working in nonprofit, it doesn't matter. You can't just blindly plug numbers into a model and just run it. You have to understand the business context or the practical context of what you're working with. And in this case, it would not make sense to fit this model with an intercept. Now, I do have, moving on to a similar point, but a related point, I do have a criticism of KNIME, which is that in linear regression, you need to check some basic assumptions. And for those of you who have studied linear regression before, these are four fundamental assumptions of linear regression. There's linearity, there's homoscedasticity, which is just a fancy word to say that the variance of the residual is the same for any value of x. There's independence between the observations, and there's for conditioning on a fixed value of x, y is normally distributed. So to be rigorous, I should have set IID, so independent and identically distributed. Okay. Okay. So unfortunately, in KNIME, you don't have. Unfortunately in KNIME, you can't get these. You can't get the usual plots that we statisticians know and love to check these assumptions. If you're working in R, then these plots are very easy to obtain. So that's this goes to another broader point that I want to emphasize in this presentation, which is, well, first of all, just to summarize, you can't get diagnostic plots for linear regression KNIME, but you can connect KNIME to R or Python using an extension node to get these plots. But the broader point that I want to make is statistics seems to be something that is not valued enough in my field. And I've worked in this field for now almost 9 years. And I'm sad when I look at a software that doesn't provide diagnostic plots to check the assumptions of a linear regression model. When I talk to people in industry and I ask them what statistics mean to data scientists, oftentimes I'm getting answers like, well, statistics is about surveys, statistics is about t-tests, statistics is about p-values, and those things are true, but to me, statistics also means things like sampling and design of experiments and simulation and based inference, like Monte Carlo simulations or Markov chain Monte Carlo. Moving on to machine learning, you've got lasso regression and random forest and gradient boosting. There's so many things that statistics offers. And if you look really rigorously between statistics and machine learning, there's really not a lot of difference between the two. I find this to be even more striking when I look at Python. What package do you use to build predictive models in Python? What I usually hear is scikit-learn, okay? And scikit-learn is definitely useful for productionizing machine learning models or predictive models in general. But scikit-learn has its own problems. So, for example, if you're using logistic regression in scikit-learn, you have to understand that regularization is applied by default. What that means is you're going to set, you may set the regression coefficients for certain predictors to 0, and that will remove the predictors from your model. Is that what you want? I know that when most people, certainly when most statisticians implement logistic regression, they don't use regularization by default. So I wonder how many people know about this default option when they implement logistic regression in scikit-learn. And I think most people would agree that logistic regression is one of the most commonly used models in scikit-learn. How many people know that? How many people know that regularization is used by default? So as a statistician, when I use Python, and if I'm not productionizing models, then I really encourage the use of stats models. So stats models is a package that allows you to implement statistical models and get the kinds of information that get the kinds of output that we know and love as statisticians. So here's the documentation page for stats models, and as you can see, if you have ever used R or SAS, you're probably familiar with output like this. Okay, if you use scikit-learn to implement linear regression or logistic regression, you're not going to get output that looks like this. Okay, so if you are using statistical models, do you understand what you're doing? Do you know the math behind what you're doing? And do you know how to tune the model according to the circumstances of your business question? And do you know how to interpret the outputs of a model like this? And if you're using scikit-learn, you're not even going to get output like this, right? So the overall message that I'm trying to say here is that as a statistician, I think that statistics is undervalued in the field of data science. And I think that it should be a key skill for everybody to learn. So here are some resources that I suggest all of you to use to consult if you want to learn statistics but haven't had the academic background like I have. So this book is free and available for you to download online. It's called An Introduction to Statistical Learning with Applications in R. Here is the page for this book, and the first edition is available for you to download. The nice thing about this book is it shows the models in fairly good detail. It doesn't show all of the derivations, but it also has a bunch of examples in R. Okay. If you want to understand the theory behind the statistics in more detail, then Penn State University has a bunch of courses that are available online. Okay, so if you search for Penn State statistics and you go to the undergraduate courses, you'll be able to find all of these courses that are available for you freely online. The notes are available. Okay, okay. So to conclude, let's talk about the business lessons first. So when you're evaluating a marketing intervention, whether it's retail coverage or any other marketing intervention in retail for consumer packaged goods, it's important that you assess the incremental impact for both the supplier's brand and the entire category of products for the retailer. Okay. If you are interested in doing data analysis, but you don't want to or don't have the skills to use computer programming to do so, and you want a free software to do so, consider using KNIME. But do know that it has some limitations for statistics. And most importantly, as a statistician, I want to evangelize this as much as I can. Statistics is an essential skill within data science. Statisticians like myself bring a lot of value and knowledge to the data-driven fields, including data science. And I encourage you to consult the resources that I have shared here to learn more about statistics. And lastly, I want to tell you all that I have started a newsletter called The Median. And this newsletter is more about developing your careers and improving your communication skills for working in data science, and also to find out what I'm observing in terms of trends in statistics and in data science. This newsletter is completely free, and I encourage you to sign up for it at themedian.substack.com. So any recommended text for those with a math undergrad background to get into ML. Okay, so I hope that that book for this book, An Introduction to Statistical Learning, is helpful for that purpose. Okay, I tried to look for free resources that are available to everyone. So this book is free, and these websites are free. Okay. What are the ML applications in your CPG industry? What are the normal algorithms used? Do you mostly use I'm guessing you mean stats models for predictive modeling. Okay. So in my job, I've only worked at Acosta for a year. I do use machine learning in my job, but it is part of this proprietary software that I cannot talk about. So unfortunately, I can't answer that question. I do know that I have heard of coworkers using quantile regression and gradient boosting. Quantile regression, if you don't know, is similar to linear regression, but instead of estimating the mean, you're estimating the median. And why would you want to estimate the median? Because the median is insensitive to outliers. So if you have outliers in your data, it will not influence your model. It will not greatly change the regression coefficients as your data change from one sample to another. So that's a nice thing about quantile regression. It's good when you're training on data that have outliers. Do you mostly use stats models for predictive modeling? I certainly do, but I do not productionize models in my job. I know that my coworkers do. I would imagine that they use other packages. Unfortunately, I don't know what they use, so I can't answer that question specifically. I definitely use stats models. Okay, how easy is it to convert your KNIME models for production and big data? I cannot answer that question in terms of gradation. I just know that you can. And I have heard from somebody who uses KNIME a lot that they don't recommend it. They still recommend you to productionize. They still recommend you to productionize models using scikit-learn or whatever else that you use in your cloud computing platforms for productionization, whether you're using AWS or Databricks. So I know that you can use KNIME to productionize models. I don't know how easily. What I've heard is unless you are really strapped for options, they don't recommend you to do so. Any advice for presenting your work to those with a non-technical background? That is a very broad question, and I don't think that I have the time to answer that in a lot of detail, but I will take that question seriously as a topic to write in my newsletter, which is called The Median. I do not use cloud solutions in my work. I have heard of others in my company using Databricks. I have also heard of other colleagues using Amazon Web Services, AWS. I have heard of people using Google Cloud Platform. So cloud computing is absolutely used in my profession, and it is a valuable skill to learn.